Okay, so today we're going to be making a virtual machine, and I got a little spinny wheel here to decide what language we're making it in. So we are going to be making it in except Python already runs in a virtual machine, so we're going to have to compile it into an executable before we actually run it. Otherwise we're going to be running a virtual machine in a virtual machine on a computer. But I think we can make this work. Okay, so we've got a completely blank slate here, so I'll be trying to make a virtual machine with nothing but Python and an unknown grade in computer science. So we won't be using any imports, since that'll kind of go against the standalone virtual machine, because we'll need to take stuff from the already existing computer. So that being said, we're going to need to define our stack, and let's make that an array. Why not? We're going to need some memory, aren't we? Let's make this 1,000. Let's make it million, shall we? Just so I don't look stupid. Yeah, that is million. Okay, I can count. Probably going to need some import to define some new stuff later. But for now, let's just go into the fetch code execute cycle. Anyone who's taken computer science knows exactly what that is. So if we just define fetch here, let's define decode. Decode, and we're going to need execute, which is going to be the larger of 3. What else are we going to need? We're going to need to actually run it. We'll just call this boot. Do like a little bootloader. I think that's it for now. So I'll quickly fill these out and then I'll get back to you when I'm done. Okay, so I filled them all in. Couple changes. I've got a binary converter here, so we can convert all in this binary. I'll discuss this in a second. I've got the fetch to code execute cycle, and we've got the boot sequence here, like the bootloader. So, first of all, it's taking the actual assembly code from this file here, the asm.txt, and then what it's doing is it's basically putting it into the stack, and then it's doing the fetch code execute cycle. This is not what it's going to be entirely, because I'm going to add another, rather than making it a 2-bit opcode. Let me show you what I mean. Okay, so in assembly, this is our little program. Okay, so basically what we're doing is we're moving the value 1 into address 0 in memory. Then we're moving the number 3 into address 1. We're adding address 0 and address 1, so that's 1 and 3, which is 4, and then it's displaying address 0, and then this can be any number because you only need 1. So, but obviously for it to work you need to have 2 numbers, but this can be anything. It's displaying number 0. By the way, the add command, it will always store the value in the very first number, address I mean, so it will store it in address 0, so we're displaying 0. So if this works, we should get 4. This isn't what it can read, however, because computers can only read machine code. So this into machine code is this right here. So what we have is we have the 2-bit opcode. So what this means, one opcode is, as you can see here, is literally just this assembly codes, but in binary. So if we have, 0 is move, 1 is add, 2 is subtract, and 3 is display. So we're doing move, and then this is the binary number for 1 into address, and then this is the binary number for 0. You get the idea, and then you just put these together and you get this. It's simple, really. So yeah, so if this works, we should get it displayed the number 4. If it works. One thing I should take this out, because this was just when I was debugging it. If we run it, we get 4. There we go. Isn't that great? So what I'm going to be doing now is I'm going to make it so it's a 3-bit opcode, because then what I can do is I can add jump, which means we can do loop. So I could do like a say jump to I don't know, jump to like address 1, address 0 in the stack. If I might have to have 3 codes actually. No, I'll just make it so it's always address 0 in memory. So okay, so sorry, I'm just thinking aloud here. So we'll do jump to the address. So we'll do jump to the address in the stack if address 1 in memory is whatever we put here. So say 1. Okay. So actually, well, yeah. So what we could do is we could do loops basically. So we could say add a number until the number is 4. So it'll be 1, jump back to the beginning, 2, 3, 4, and then it will carry on with the loop. So we can add jump, and we can also add an end command, which basically means we don't have to do this, because at the moment I'm having to manually do this. So for range 4, because we've only got 4 things here, it will do the fetch code execute cycle, but I don't want to have to do that, because that means we can't make any program we want, because we have to keep editing it in the code. So what I'll do is I'll just make it until we have an end code like command, and then the fetch code execute cycle will finish. So yeah, see you in a sec. Okay, so as you can see, I've actually put it all into one while loop now, because basically in order to add the jump command, I needed to be able to modify the program counter during the execute function, which I couldn't do. So I've put it all into one massive while loop, and it's actually made it a lot more compact as well. This is the whole virtual machine. Now what I've added down here, I've done like the codes here, so you can see I've added jump and end, and I also have one more, but I can't think of what to add yet. And what this means is basically we can have a program as long as we want it, and we can just put end at the end and it will finish then. Now the jump, what that allows us to do is obviously loops, like I said. So what I've done is I've made another little program here, which is basically the exact same program as before, except it's going to jump to address 3 in the stack, which is here, and if memory address 0 in memory is equal to 2. So what does that mean? So basically what we're doing before is we're adding 1 and 1, and we're saving it in memory address 0, and then we're displaying it. So that's going to display 2. Now what this is doing is basically an if statement, so it's saying go here if this is 2, if memory address 0 is 2. So, and which it is. So what it's going to do is it's going to see memory address 0 is 2, so jump to address 3 in the stack, which is here, which is going to add memory address 0 and memory address 1, which is going to add 2 and 1, so it's going to have 3, it's going to display 3, it's going to realize it's 3 not 2, so we're not going to jump, and it's going to end. So it should display 3 and 2, no sorry, 2 then 3, if this works. So there you go. So it's added 1 and 1, it's jumped back to the addition, added 2 and 1, and now we've got 3. So our assembly language works basically, and we have a very small virtual machine that we can actually run assembly code on, which is it's pretty cool, especially that it's made in Python, which is in itself running in a virtual machine. So I hope you enjoyed. Thanks for watching, like, subscribe, all of that, and see you in the next video.